Hello. In the last video, we discussed that the connection between the client and the server is a long-term connection, is a stateful connection, and that connection actually helps server in sending events to the client. So as you can see, the connection has been established, and now server can send multiple events, multiple messages, you can say, to the client, and the client can then receive them and then use it for the user, for the viewer. The benefit of this is every time when there is an event, for example, we are talking about likes, and users are liking video very fast. So if you have a normal connection, which is an HTTP stateless connection, in which after every like, if connection is getting disconnected, then this can be a big issue, because every time it's disconnecting, then reconnecting, disconnecting, reconnecting, and you can say that's not how the application would work. So once you have a stateful connection, the stateful connection is helpful in sending frequent responses to the client, as in this case. So we have a like here, for example, this is a like, this is a like plus comment, and also this is a like plus comment. So if server wants to close the connection, that can be done easily by the server at any point of time, and server can say, okay, that's it, I want to disconnect, and here you can close the connection. Now we will understand and we will see that what technology LinkedIn used to establish this connection and how those connections were managed. LinkedIn used the Play framework with Akka actors. What is Akka? Akka is a toolkit for building highly concurrent, distributed, and resilient message-driven applications. Now let's look further. So Akka actors are objects which have some state and they have some behavior. So if I draw the Akka actor here, for example, we have this Akka actor. Let's say this box is an Akka object, and we have a state and we have some behavior. Behavior defines how the state should be modified when they receive certain messages. So this Akka object, so let's say this is Akka, this Akka object behavior can be defined when they receive certain messages. Each actor has a mailbox and they communicate exclusively by exchanging messages. So the actors have mailbox, and in this mailbox they have different messages. For example, these are messages. One Akka actor manages one persistent connection. So if we have a connection between the user, between the client and the server, so one Akka actor can manage one connection. So one Akka object can handle one connection easily. Okay, threads and Akka. An actor is assigned a lightweight thread every time there is a message to be processed. That thread will look at the behavior that is defined for the message and modify the state of the actor based on that definition. So we have different Akka objects, as we can see here, and these green lines are the messages which Akka object contains, and these different Akka objects are actually handled by the thread. T1 is handling the first Akka object, and the T3 is handling the fifth Akka object. Then once that is done, this thread is actually free to assign to the next actor. Since actors are so lightweight, they can be millions of them in the system, and each can have their own state and their own behavior. So for example, this T1 is handling the Akka1 object, and once it's done with the work, so this can be assigned. The T1 can then handle Akka2 object, and T2, for example, handling the Akka3 object. And once T3 finishes its work, now the T3 can, for example, we can tick mark like it's done, and this is also done, and then the T3 can handle this Akka object. So since the Akka object are very lightweight, we can have them in millions of numbers depending on the system. A relatively small number of threads, which is proportionate to the number of cores, can be serving these millions of actors all at the same time, because a thread is assigned to an actor only when there is something to process. So the thread manages the life cycle of the Eka object, and Eka objects are very lightweight, so we can have millions of Eka objects. And we already have discussed that one Eka object handles one connection, right? So if we have millions of objects, so it means we can have millions of connection, and using those connection we can send different messages which are likes or comments. Okay, now we have this delivery system, and in this delivery system what we have an Eka manager. Eka manager actually handles all these individual Eka objects. So Eka manager is actually handling all the individual objects, the life cycle of these objects, right? And then these individual objects are connected to the different devices, and these are persistent connections. So, and let me connect all these devices with the Eka objects, Eka actors. Now we have the backend system from where we get the likes or the comments. So for example, we have a like here, and then this like is, and the backend is actually connected with the Eka manager. So this like is sent to the Eka manager, and this Eka manager then sends this like to the appropriate Eka object, and then from there it is then sent to the viewer who is watching the video. And this is how this whole cycle is working. So we have backend which is connected to the Eka manager, and the Eka manager handles individual Eka objects, and these Eka objects are in connection. They have a connection with the clients, the persistent connection. As the Eka actor gets any event, it then publishes that event to the subscribers. So this looks like a good design, and we can handle thousands or maybe millions of users, and we are able to pick up events and transfer data to the end user. But there is a little problem with this design, and the problem is how we can handle multiple videos being watched by our users. Now let's address this problem. So this is the scenario now where we have user 1 is watching video 1, user 2 is watching video 1, user 3 is watching video 2, and user 4 is watching video 3. So we have multiple users, user 1 and user 2 watching video 1. So user 3 is watching video 2 and user 4 is watching video 3. So how we can handle this? This is our real-time system. This is our real-time delivery system. And in this system, as we saw, we have actors. So for example, we have different Eka actors. So these are all Eka actors, and we have 4 Eka actors. And these 4 Eka actors are handling persistent connection with our users. So, and with that, we also have Eka manager. But how we will handle this? So we will use something like subscription. So these users will subscribe, and the Eka manager will handle these subscriptions in a specific table. And the table is something like this. We will have user ID, for example, and we have video ID. And this table will have entries like user 1 is watching video 1, user 2 is watching video 1, user 3 is watching video 2, and user 4 is watching video 3. Our manager will handle the subscription, and the user, this information is then transferred to the manager. The subscription, the different subscribers will subscribe to the manager, and manager will store this information. And when we have the likes on different videos, then that information will be transferred to those subscribers. So we have the same backend system, and with this backend system, this is connected to the manager, and this backend system gets a like. Now, when this backend system gets a like, we will a GIF, the backend system will transfer this to the manager. The manager will determine for which video this like is, and then the manager will transfer this one to the appropriate Akka object, and the Akka object will transfer it to the user. For example, this one is for the video 2. So this manager will transfer this to the Akka object, which is handling the video 2, and then this will then transfer to the user, and he will receive this information. So this is how LinkedIn engineers manage this problem. So every user has to subscribe. The Akka object gets the information. The manager handles the subscription and the different videos. And as they got the like, the manager then filters out for which video it is, and then it's published for those users.